Today we're going to learn about identifying functions. Functions are a relationship between an input and an output on a one-to-one ratio. Let's say we're given some domain and some range. Let's say the values are 2, 1, 0, and 3. Now if each number in the domain is mapped to a number in the range, then we have a function. For example, if we were to graph this function where x is the domain and y is the range, and let's label these points A, B, C, and D. Then we would have -2, 3 as A. We'd have 1, 2 as B. We'd have 0, 1 as C. And we'd have 3, 4 as D. Now this is a function because each point in the domain has one value in the range. Now if the number 1 was mapped to 3 instead, would this still be a function? Well, the answer is yes. And we should actually bring these values to the domain side because several of the values in the domain can lead to the range, but not the other way around. So this would mean that B now has a value of 3. And it would be up here instead of down here, where it used to be. And this is still a function. A function that consists of points that are not connected, so points like these, that do not have line segments connecting them, this is considered a discrete function. On the other hand, we have a continuous function. So if we were to draw a line through these points, this would be a continuous function. A continuous function is connected by an unbroken line or curve. In this case, it's a curve. Now over here, I created a table instead where we have values in the domain and values in the range again. Now, is this a function? Again, a function is something that has a one-to-one ratio. As in, every value in the domain has one specific value in the range. Now, the reason this is not a function is because the value of 4 in the domain has two values in the range, 2 and -2. And a value in the domain can only have one value in the range. So this isn't allowed. And as we see the points on the graph here, we see that the first one labeled B is right here, and the second one labeled D is right here. Now, what do you notice about these points? Well, they're on top of each other. And so if you drew a vertical line, they'd both be on the line. And so what's a way that we can figure out if a set of data points, when graphed, is a function or not? We have the vertical line test. If the line intersects the graph more than once, it's not a function. So we can draw a vertical line anywhere on the graph here. In this case, we're doing it on the value of x that is 4. And in this case, it intersects B and D, which means that it's not a function. So what are some examples of functions? Functions could look like this, where a vertical line test would only hit one point on the graph. It could look like this. This is also a function. In this case, the function is y is equal to the absolute value of x. This is not a function, as the vertical line test fails here. And same as a function that looks like this. Vertical line test fails again. Goes through 2 points.